Okay, imaginary and complex numbers. It's something that you're going to study in Algebra 2 and then every year after that. And it's not, please don't think it's just made up math. I know it's the word imaginary, but it's not made up math. These are actual things. You just can't graph them in the real world. But the reason they exist, an imaginary number exists for this reason. If I asked you to do the square root of 9, hopefully you would know that the answer is 3. But if I ask you to do the square root of negative 9, hopefully that would stump you, because even if your gut told you to answer negative 3, that's not right, guys, because if I worked backwards and I took this negative 3 and squared it, would it in fact equal negative 9? Well, no, it wouldn't, because negative 3 times negative 3 is a positive 9. So there's no way to make a negative happen underneath the square root. And so somebody came up with this imaginary number system. So if you have the square root of negative 9, you're not just stuck. You get to answer the question. And the way that you answer that question is you can think of it as the square root of negative 1 times the square root of positive 9. Because we know that that is the same as that, right? You can break it apart. And by definition, the square root of negative 1 is I. And what's the square root of 9? Well, it's just 3. So we usually put that number in the front, kind of like a coefficient. But that would be the answer. And that's the point of an I. So what happens when you're working with I's and you're trying to simplify them? Well, there is something called, I call it an eye chart. And I don't know if that's just like a me thing because I have bad eyes and I always think of the eye chart at the doctor's office or whatever. But basically, if you have a square root of a negative 1 and you get I, well, the answer is just I. But if you start taking I to different powers, you end up with different results. And I'm not going to prove all this for you. I'm just going to say this is going to be very worth your time in memorizing. And if you can't read my writing, this is an I. This says I squared equals negative 1. I cubed is negative I. I to the 4th is 1. And you're going to use these in case you're given something like I to the 13th. And you have to simplify that. The idea would be that this runs on a loop. It's a pattern. And every 4 numbers it starts to repeat. So this would be like I 1, 2, 3, 4, but then it would be I 5, 6, 7, 8, 9, 10, 11, 12, 13. So the way that you can solve these out, rather than counting every time, is to take this exponent and divide it by 4 and look for the remainder, okay? So 4 goes into 13. How many times is that? 3 times, with a remainder of 1. And the remainder of 1 tells you that you're going to end on this first answer right here, and you're going to get I. If it was a remainder of 2, you would match I squared. Remainder of 3, you would match this one. And a remainder of 0, you would match this one. And these are the answers that you always want to give your teacher. You don't actually give them this column. Don't answer this way. Answer with this side. And that's how all your problems should look, okay? So now what else can you do with these? Well, if you are adding or multiplying imaginary numbers, like 2i minus 3i plus 7i. Okay, these things operate just like an x term, like a variable. You would just focus on the coefficients and do the math. 2 minus 3 plus 7. Well, that would be a 6i. And that's how you'll answer your question, okay? Now, once we start putting real numbers with imaginary, that, my friends, is what is called a complex number. And a complex number is usually written in the form a plus or minus bi. You've probably seen this in class. A is the real number. B is the imaginary number. And so it has both parts, okay? And so pretty much every number that exists, guys, is a complex number. You just haven't been taught that your whole life, and now they're throwing it at you like, oh, by the way, all those numbers you've known, yeah, they're all complex numbers technically. But that's okay. That's another story. So what are we going to do with these? Well, if we wanted to put together the complex number 2 minus I plus another complex number 3 plus 6i, then we can do that, okay? You just make sure you look at what's going on between them and do exactly that. If we're adding them together, you need to think, just like I said earlier, pretend it's like a variable, like an x. You need to do the real number with the real number, so 2 plus 3. You need to do the imaginary term with the imaginary term. So what is a negative I plus a 6i? 5i? All right. That would be your answer. So it's like your answer's also going to have this a plus bi right here. You know, it's going to look the same, so we know we answered it right. Okay, what about if we're subtracting? Well, if we're subtracting, be really careful because people mess this up all the time. All the time. They're not careful with this negative. If it helps you, I recommend that you make that a plus and go ahead and distribute the negative inside of your parentheses, and then it makes it just like the one that we did up here, okay? So all you have to do is, once again, 3 plus a negative 4i, and then a negative, I'm sorry, that wasn't an I, that was just a real number, negative 2i minus 1i. So I'm just doing the coefficients, guys. I'm just doing combining like terms. CLT, that's all I'm doing. How does it get harder, you might be thinking? Well, let me show you. What if I multiplied instead of adding or subtracting? Okay, if I'm going to multiply, I need to make sure, once again, I'm going to treat it as if this was an x, and I'm just going to like FOIL it. I'm just going to multiply it. So if I multiply it out, I'm going to get 6 minus 3i plus 10i minus 5i squared. Okay, now if you want to clean this up a little bit, see how these two middle terms actually both have an I, so I can put their coefficients together. Okay, now you're actually not finished. You're still not done. Remember earlier when I said if there's an exponent on the I, you actually don't want to leave that as an answer. So I'm going to scroll back up. So if you get motion sick, close your eyes for a second. I need to replace this I squared with what I wrote up here, okay? Now up here, I squared maps to -1. It's the same thing as a -1. So I'll come back down, and I'm going to replace that I squared with a -1. And the relationship here is just multiplication. So if I've got a -5 times a -1, it's just a plus 5 back there. And then I can put my real parts together. Look, see, combine like terms, 6 in the front, 5 in the back. And that would be my final answer. Okay? And the last part of this, what might be the most difficult, is the division. Because the whole thing is like people look at this and think, what is the deal? Like, what's the point? Like, how do I divide these? We're not actually going to do division here. That's what's weird. We're not going to divide. What our goal is to get the imaginaries out of the denominator. That's pretty much our goal, okay? So in order to get the i's out of the denominator, you need to multiply by what's called a conjugate. I think you've heard that term before, and you've used it in other parts of the year, but a conjugate is when you take this and you switch the sign in the middle. And the reason you're going to do this is it's kind of like a math trick, and it's going to clean up our denominator very nicely, okay? So the top, I'm going to have to FOIL, and then the bottom, I'm going to have to multiply out, and let's see what happens. So I'm going to go pretty quickly on this because I assume you know how to multiply. So I'm going to multiply the top, so that'll be a 3 minus 3i minus 2i minus 2i squared. On the bottom, I'm going to have a 1 minus I plus I minus I squared. Okay? And so now I'm going to clean this up. So in the numerator, remember, what is that happening? I squared is really a -1. So -2 times -1 is really a plus 2 up there on the top. Notice I just put the two middle terms together without mentioning it. There it is. On the bottom, look what's going to happen. These two middle terms are going to cancel out. That will happen every time. Okay, that's the point of doing this. Okay, that's the goal. It cancels out the crap in the middle, and it just leaves that 1 in the front, and then the minus I squared in the back. And that I squared, I'm going to go ahead and turn into a -1. Okay, So now what? Now we clean it up. We got a 3 in the front, a 2 in the back. And on the bottom, I have 1 minus -1. Well, that's the same as plus plus, so I got a 2 on the bottom. So I'm pretty much finished. If you are told to write your answer as a plus or minus bi, you just want to split this up into 5/2 minus 5i over 2. And now you have the real number part and the imaginary number part, and that could be your final answer. Okay? Just read your directions. But that's it. There's no more I in my denominator. I got rid of it, and that's the goal with division. So I feel like this video is already getting too long. If I didn't cover something that you want help with, just let me know. Thanks.